Hi guys, welcome to today's session on linear inequations. First of all, let's understand what is inequality. So inequalities are used to portray relationship between two numbers. Let's say we have the number 7 and we have the number 9. So we can write 9 is always greater than 7. So to portray the relationship between 9 and 7, we can use an operator that is a greater than. It means that 9 is always greater than 7. Similarly, if we have numbers such as 5 and a number 7, and if we want to compare these two numbers, we can say 5 is always less than 7. So this kind of relationships are portrayed using inequalities. So what kind of relationships are there? We have four kind of relationships. First of all is a less than relationship. Second of all is less than or equal to relationship. Third is a greater than relationship. And fourth is a greater than or equal to relationship. Now let's understand each relationships very carefully. Let's say we have a variable x and we say x is less than 2. Now what does that mean? It means that x can assume any value that is less than 2. So if we have the number line and we want to represent the values, the set of values that x can take, we can represent it using a circle at point 2 and an arrow on the left side of the number line. This arrow indicates that these are the values that the variable x can take, and the open circle on 2 indicates that x cannot take the value of 2, but it can take any other value that is less than 2. So it can take a value that is 1.9999, but it just cannot take the value integer value 2. So it can have this, it can have 0, it can have minus 100 and up to minus infinity. It can assume any values that is less than 2, unless and until any other constraint is given about x. We can say x can assume any value that is less than 2. Now let's talk about less than or equal to relationship. If we say x is less than or equal to 2, then x can assume any value that is less than 2, as well as it can assume the value 2. So the only difference between the previous inequality and this one is the inclusion of the value 2 in this set of values that x can take. So this set will contain 2 and all the other values that the previous set would contain, and it can take values up to infinity. Now let's take another inequality that is greater than inequality, and we take a variable x and we write x is greater than 4. Now again it means that x can assume any value that is greater than 4, and to represent that we can put an open circle on 4 and indicate an arrow on the right side of the number line, and the direction of the arrow indicates that it can assume any values that is greater than 4. So x can take values such as 5, 6, 7, 10,000 and up to infinity. And greater than equal to 4, or x is greater than equal to 4, would include all the values that the previous inequality would include, as well as it will include the value 4. So 4, 5, 6, 7 up to infinity. So I hope the idea of these inequality symbols are clear to you guys. So now let's understand linear inequations. So linear inequation is an inequation that involves a variable, and the highest power of the variable would be 1. So an equation such as x minus 2 is greater than 0 is a linear inequation. Linear inequation would contain an inequality sign, and it will also contain a variable which has a highest power of 1. So since x has a highest power of 1, this kind of inequality or inequations are called as linear inequations. Now let's try to understand two terms here. First is a replacement set and second is a solution set. So a replacement set is a set from which the values of the variable are substituted in an inequation. For example, let's say we take this inequation and the replacement set can contain any values that x can assume. So 1, 2, 3, 4, 5, 6, 7. Let's say according to our condition, x can assume only these values. Now, what is a solution set? A solution set in an inequation are elements from the replacement set which when substituted in the inequation satisfies the inequation. So the values from the replacement set when substituted to the inequation, the values that satisfies those inequation would be the values that would be included in the solution set. So x minus 2 greater than 0 means x is greater than 2. So the solution set for this replacement set and this inequation would be values that are greater than 2. So values such as 3, 4, 5, 6 and 7 would be the solution set for this inequation for the given replacement set. So replacement set, solution set and the inequations are closely connected to each other. Now let us understand why we need the concept of a replacement set. We can understand the concept of solution set, that the solution that satisfies the inequality are the solution set. But why we need a replacement set? Let's understand by using a few practical scenarios. So let's say Sam has fewer than 10 apples. How do we represent that in a linear inequation? So let's say we take apples as A and we say Sam has fewer than 10 apples, which means A is less than 10. Now, what are the values that A can assume? So we cannot say an apple, Sam has half an apple, or he cannot go to the market and get 1/4 of an apple. He has to buy apples in integers, in 1, 2, 4, 5, something like that. So the replacement set for this apples would be integers. So the replacement set would only contain integer values. As well, apples cannot be negative. So Sam cannot have minus 2 apples. It doesn't make any sense in the practical scenario. So it will always have values that are greater than or equal to 0. So it can contain all non-negative values. Now the reason why I call it non-negative is because of the inclusion of the value 0. Since 0 is neither positive nor negative, we cannot call this set as a set of positive numbers. We have to call it as non-negative numbers because since 0 is there and we want to exclude all the negative numbers, it's better to call it a non-negative number set. So the replacement set will contain values such as 0, 1, 2, 3, 4, 5 and let's say up to infinity. It can contain all these values. Apples can be 10,000, 100,000, any values. But the solution set for this scenario is Sam has fewer than 10 apples. So Sam can have 0 apples, 1 apples, 2 apples, or all the way up to 9 apples. But since it's not less than or equal to 10, it cannot assume the value 10. Let's take another practical scenario. Let's say I live in a 10-storied building and I live on the 2nd floor. Excuse me. And I say Jack lives at least 3 floors above me. So the replacement set for this scenario would be, in a 10-storied building, we can have people living on the ground floor, we can have people living on the 1st floor, 2nd floor, and all the way up to 9 floors. And the solution set for this inequality would be values that are at least 3 floors above the second floor, that is 5, 6, 7, 8 and 9. 8 and 9. So these would be the solution set for the given replacement set. So I hope you guys understand what is the utility of a replacement set. So when there are conditions for the variable x, or when there are limitations for values of that x can take, we use the concept of replacement set. But now most of the times a replacement set information would not be given, and then we have to assume that x can take all the values. So all real numbers would be the values that the replacement set contains. So if nothing is given, then we have to take that as an assumption. Now let's understand a few operations that we can perform on an inequality and understand why we need to perform those operations. So to understand that, we need to understand certain rules that are applicable to an inequality. Let's say we have an inequality x minus 5 is greater than 12. So an addition or subtraction rule is used in an inequality to simplify the inequality. Let's say we have x minus 5 greater than 12, and we want to simplify the inequality such that we understand what are the values that x can take. So in order to do that, some operations we can do is add or subtract same numbers on both sides of the inequality. Let's say we have this inequality, so to simplify the inequality we can add plus 5 on both sides of this inequality. So x minus 5 plus 5 would be x, greater than 12 plus 5 would be 17. So adding a positive number on both sides of the inequality sign does not change. Let's say we have 9 is greater than 8, and on both sides of this inequality we add 1. So 10 would also be greater than 9. Similarly, if we subtract 2 from both sides of this inequality, the symbol of the inequality will not change. So 10 minus 2 would be 8, is always greater than 9 minus 2 is 7. So if we add or subtract any number from both sides of the inequality, the sign of the inequality does not change. So any other example, let's say x minus 21 is greater than 23, and to simplify that, if we add 21 on both sides of this inequality, so x, this side would be x and the other side would be 44. Again, since we are adding 21 on both sides of this inequality, the sign of the inequality did not change. Now let's see how a multiplication or division can be done in an inequality. So let's take a simple example. Let's say we take 8 is greater than 4. So 8 would always be greater than 4. Now let's say we want to divide this by a positive integer. So let's say 8 divided by 2 is 4 and 4 divided by 2 is 2. Now still the inequality sign is true. So 4 is also greater than true. So we can observe that when we divide an inequality with a positive integer, the sign of the inequality does not change. Now this is not true when we divide this number with a negative number. Let's say we have 4 is greater than 2, and now I want to divide that with negative 1. So on this side I have minus 4, on this side I have minus 2, but now minus 4 is not greater than minus 2. Actually the opposite happens. Minus 4 is less than minus 2. So here the observation is, if we multiply or divide an inequality with a negative number, the sign of the inequality changes. So let's take an inequation. Let's say 2x plus 5 is greater than 1. So now in order to simplify this inequality, I'll add negative 5 on both sides of this inequality like we did as an addition subtraction rule. So now on this side of the inequality I have 2x. On this side, since I am subtracting 5 from both sides or adding minus 5, this side would become minus 4. Now in order to simplify this inequality and get a value of x, I need to divide this both sides by 2. So x is greater than minus 2. Now please observe, since I divided the inequality by a positive number, the sign of the inequality did not change. So the sign remains the same. However, if we consider this inequation, 3 minus 2x is greater than 1, and we simplify this inequation by subtracting 3 on both sides of this inequality, so it becomes minus 2x greater than 1 minus 3 is minus 2. Now in order to further simplify it, we need to divide x both sides of this inequality with a negative 2. But as we divide the inequality on both sides with a negative number, the sign of the inequality gets reversed. So our inequality will have x is less than 1. So the observation that we can make here is, when we multiply or divide both sides of an inequality with a positive number, the sign of the inequality does not change. But when we divide that with a negative number, the sign of the inequality changes. So multiply or divide with a positive number the sign does not change. But when we multiply or divide with a negative number, the sign reverses. So no change, and there's a change. Now using these rules, we'll try to solve various inequality questions from here on. But before we do that, let's see some of the steps that we can follow while solving and linear inequations. So the first step that would be to isolate all variable terms on one side and all constant on the other sides. And to do that, we can use the addition subtraction rule. For example, let's say we have 2x plus 4 is greater than 3x plus 5. So now in order to collect all variable terms on one side and all constant terms on the other side, we can use the addition subtraction rule. So first of all, let's subtract 3x from both sides of this inequation. So if we subtract 3x on both sides of this inequation, then equation becomes 2x minus 3x is minus x plus 4, and 3x minus 3x is 0. So only 5. Now to isolate all the constant on the other side, let's subtract both sides of this inequality with a negative 4. So when we subtract both sides of this inequality with a negative 4, the inequality becomes minus x greater than 5 minus 4 is 1. So using the addition and subtraction rule, we simplified this inequality, and then we can represent this inequality very easily in a number line. So it would need a little bit of further simplification. So we have to divide x with a negative 1, and that would be x less than negative 1. So we can implement it as minus 1 with an open circle and an inequality to the left of the number line. Now let's come to the second rule. If any fraction or decimals are involved in an inequality, remove those fractions or decimals by multiplying both sides by an appropriate factor. Let's say we have 2x divided by 5 plus 1 is greater than 5. So first of all, we try to isolate all the like terms on one side and the unlike terms on the other side. So to do that, we subtract 1 from both sides of this inequality. So 2x divided by 5 is greater than 5 minus 1, that is 4. Now, in order to simplify this, we need to multiply this inequality by 5 on both sides to remove this fraction. So we need to multiply both sides by 5. Since we are multiplying by a positive number, the sign of the inequality would not change. So the inequality becomes 2x is greater than 5 times 4, that is 20. So using this fraction or decimal, so if a fraction or decimal is involved, we simplify it by multiplying or dividing by an appropriate factor. And here the appropriate factor was 5. We multiplied 5 on both sides to get the, or to simplify this inequality. The third rule is to make the coefficient of the variable 1 by dividing both sides of the coefficient with the coefficient of the variable. Let's say we have 2x plus 5 is greater than 1. So we use the addition subtraction rule to get the like terms on one side. So here we'll subtract 5 on both sides of this inequation, or we add a negative 5 on both sides. So here adding the negative 5 will make it 0, and on the other side adding a negative 5 would make it minus 4. Now to isolate the value of x, or to get a value of only x, we need to divide both sides with the coefficient of the x, or with 2. So now we divide both sides with 2, so x becomes greater than minus 2. And here note that since we are not dividing with a negative number, the sign of the inequality does not changes. And the last rule is, when no replacement set of a variable is given, then the replacement set is by default a replacement set of all real numbers. That is, all numbers that can be plotted on a number line, that are integers, fractions, positive, negative, any numbers, right? So using these toolkits and the steps that I discussed, let us solve a few problems and make our understanding a little bit better. Let's go with problem 1. It's given that x belongs to 1, minus 3, minus 4, minus 5, minus 6. So this is our replacement set. So this is our replacement set. And the inequation is 13 less than equals to 1 minus 3x. And it's asked to find all the possible values of x, and also represent its solution set on the number line. So first of all, let's simplify this inequality. So our objective is to collect the like terms on one side and the unlike terms on the other side. So let's first of all simplify it by adding a negative 1 on both sides of this inequality. So adding a negative 1 would make this side as 12 less than equals to negative 1, and positive 1 makes it 0, so minus 3x. Or we can also write it as minus 3x is greater than equal to 12. And now in order to further simplify it, we need to divide both sides of this inequality with a negative 3. But as we are dividing both sides with a negative number, the sign of this inequality would change. So 12 divided by negative 3 is negative 4. Now let's represent this in the number line. So since x is less than or equal to negative 4, so we know x can take the value of negative 4. So we represent that with a closed circle. And we represent the values that x can take by an arrow on the left side of this number line. So x can take all the values that is shown in the number line, x less than minus 4. So the solution set will contain all these numbers. But here, since we are given a replacement set, so the solution set for this replacement set would be values that are less than minus 4. So values that is minus 4, minus 5, and minus 6. So for this given replacement set, the solution set would be minus 4, minus 5, and minus 6. but if no solution set would be given, then the solution set for this inequation would be any values that are less than 4. So all the values that I have shaded in the number line. But for this given condition, for this given replacement set, the solution set is -4, -5, and -6. Now let's go and solve another problem. Find the range and value of x which satisfy the inequation 1 by 6. So let's write the inequation again. 1 by 6. So 1 over 6 less than equals to 2x over 12 plus 1 less than equals to 4 over 12. I'm sorry, there is no equal to, so I'm gonna remove the equal to here, and so 2x plus 1 less than 4 by 12. Okay, so now let's simplify it. So first of all, let's multiply both sides by 12 to simplify it. So we know that when there's a fraction involved, we need to simplify it by multiplying it with the appropriate factor. So here we have 12, 12, and we have 6. So the LCM of this is 12. So I'll multiply the entire inequation with the number 12. So the inequation forms, so 1 by 6 multiplied by 12 would be 2 less than 2x, and 1 multiplied by 12 is 12 less than 4 by 12 multiplied by 12 is 4. Now we need to isolate all the like terms on one side. So here we have a variable and a constant. So to isolate this, we need to subtract 12 on all sides of this inequality. So if we subtract 12, it becomes 2 minus 12 is minus 10 less than equals to 2x less than equals to 4 minus 12 is minus 8. So now in order to further simplify it, and since we have a coefficient of this variable x, we need to remove this coefficient by dividing the coefficient on all sides of this inequality. So when we divide this inequality with a positive number 2, we know the sign of the inequality does not change. So finally the equation becomes minus 5 less than equals to x and less than minus 4. I'm sorry, there would not be a equal to sign here. So let's try to represent this solution set on the number line, which is also asked in the question. So x can take a value minus 5 and it cannot take the value minus 4, so there will be an open circle here and there will be a closed circle here, and these are the only values that x can assume. So minus 5 and less than 4. Okay guys, so let's move on to our next question, and this is going to be the last question for this session. So in this question, P is given as the solution set of this inequation and Q is given as the solution set of this inequation, and we are asked to find the set P intersection Q. So let us solve this problem step by step. Let us find P, that is the solution set of 8x minus 1 greater than 5x plus 2. So as we already discussed, we need to simplify this inequation by getting all the like terms on one side and the unlike terms on the other side. So in order to do that, let's add negative 5x on both sides of this inequation. So 8x and a negative 5x gives a 3x minus 1, and on the right hand side negative 5x and a positive 5x gives 0, so it's only 2. Next we need to move all the constant terms on one side of this inequation. In order to do that, we add a positive 1 on both sides of the inequation. So 3x minus 1 and a positive 1 is only 3x, greater than 2 plus 1 is 3. And finally the last step would be to divide both sides of this inequation with the coefficient of x. Here the coefficient of x is 3, So we divide both sides by 3, and since we're dividing with a positive number, the sign of the inequality does not reverse. So the solution set for P is x greater than 1. Now let's find the solution set for Q. So for Q, it's given as 7x minus 2 is greater than 3 times x plus 6. So here, first of all, let's simplify this right hand side of the equation. So 7x minus 2 greater than 3 times x is 3x plus 6 times 3 is 18. Now, as we discussed, our objective is to get all like terms on one side. So to get all x on the left hand side, we add a negative 3x on both sides of this inequation. So 7x minus 3x, that's 4x, minus 2, and negative 3x and positive 3x is 0, and on the right hand side only 18 remains. Now next objective is to move all the constant terms on the other side of the inequation. In order to do that, we add positive 2 on both sides of this inequation. So 4x and negative 2 and positive 2 is 0 is greater than 18, and positive 2 makes it 20. And the last step is to divide both sides of the inequation with the coefficient of x, and here the coefficient of x is 4, so we divide both sides by 4. So 4x over 4 is 4, and 20 over 4 is 5, so x greater than 5. Now our objective is to find the intersection of P and Q. So let's first plot P on the number line. P is x greater than 1. As we discussed, we plot it with an open circle on 1 and an arrow on the right side of the number line, representing the values that x can take. And Q is x greater than 5, so open circle at 5 and an arrow to the right side of the number line indicating the values that x can take. So the common area or the intersection would be the area that is shaded in the number line. So the common area is essentially x greater than 5. So the solution set for P intersection Q is x greater than 5. So in our next session, we'll be solving more practice questions to reinforce your concepts further on inequations. I hope you guys liked the video, and we'll see you in the next session. Thank you for joining. Goodbye.